Welcome to my channel Simple Concepts by DJ. Today we are going to discuss about a numerical problem in the lesson effects of electric current. In a Joule's calorimeter experiment, the temperature of a given quantity of water increases by 5 degrees Celsius. When current passes through the resistance coil for 30 minutes and the potential difference across the coil is 6 volt. So we need to find the rise in temperature of water if current passes for 20 minutes and the potential difference across the coil is 9 volts. So this is the question. So we need to solve it. So before jumping into the act of solving the problem, I just wanted to explain what is the question is all about. So here a Joule calorimeter experiment is being conducted, and in that experiment the temperature of the quantity of water, so the temperature of the water increases by 5 degrees Celsius. So what does it mean? There is a difference in temperature of about 5 degrees Celsius. So when a current passes through the resistance coil for 30 minutes, how there is an increase in the temperature of water? There is an increase in the temperature of water when there is a current which passes through the resistance coil. For example, this is the resistance coil. This is the resistance coil. Here the current is passed through the resistance coil. Okay, so water is here. Water is here. So when the current is passed through the resistance coil, the temperature of the water, there is a difference in temperature of water which is 5 degrees Celsius. So the current is passed for 30 minutes. The time interval that has been recorded for the passage of current is 30 minutes. And while the passage of current, when current is passing through the resistance, a voltmeter is being connected across the resistance coil, and the voltage value is recorded as 6 volts. Now they are asking us to find the rise in temperature of water if the current passes for 20 minutes. Now they are changing the time interval from 30 minutes to 20 minutes, and they are at 20 minutes, and they are asking us to find the rise in temperature of water provided if a voltage is being measured across the resistance coil. At that instant, the value of the voltage will be 9 volts. So that is the explanation of this numerical question. Okay, so let's get started with the problem. So for this question, I'm going to use a formula which is H equal to W into d theta. Okay, W into d theta. So what is H? H is the heat that is being produced, because when there is an increase in the temperature of water by 5 degrees Celsius, automatically the heat energy will be produced. That heat energy is equivalent to W into d theta. What is W? W is nothing but the heat capacity of the calorimeter apparatus. Okay, and d theta is nothing but the change in temperature. Change in temperature is theta 2 minus theta 1. Theta 2 is considered to be the final temperature and theta 1 is considered to be the initial temperature. So that is d theta. So H equal to W into d theta. This is the formula I'm going to use. Now what is H? Before getting into the step of solving this one, we need to find what is the value of H. H is equal to V into I into T. Okay, that is nothing but the product of voltage, current and the time interval. So we are given the voltage value, we are given the time interval value. Okay, so we can use this expression and we can substitute VIT in place of H. This is what I'm going to do. Okay, this is the formula which I'm going to use in this one. So before getting into it, from the question, I'm going to extract the data so that it will be easy for us to solve the problem and get the answer immediately. Right. So here the quantity of water increases by 5 degrees Celsius. Increases by 5 degree means it is not the temperature value, it is the increase in difference in temperature. Okay, so that is nothing but d theta. So they have given with the value d theta, which is nothing but 5 degrees Celsius. This is 5 degrees Celsius. Okay, and they are asking us to telling that it is the current is passed for a time interval of 30 minutes. 30 minutes means time interval t1 is equal to 30 minutes. So 30 minutes converted into seconds, 30 into 60. If I multiply 30 into 60, it will be uh, 1800 seconds. Okay, so 1800 seconds, that is time interval t1, 1800 seconds, right? And they are telling that the potential difference that has been developed across the coil is 6 volts. So which is nothing but V1. V1 equal to 6 volts. V1 equal to 6 volts. So this is the first set of value. Okay, now we need to find the second set of values. We need to extract the data for the second set of experiment that has been conducted using the Joule calorimeter apparatus. So what is the second one? Now they are asking us to find the rise in temperature of water. So the rise in temperature of water, what we do is we denote it as d theta dash. D theta dash is something which we need to find. Okay, so if current passes for 20 minutes, now the time interval is given for T2, which is nothing but 20 minutes. 20 into, since again minute converted into seconds, so I need to multiply 20 with 60. So it will be 20 into 60 is nothing but 1200 seconds. So the value is 1200 seconds. That is 1200 seconds, right? So what is the voltage that has been developed in the second set of experiment? In the second set, the voltage developed is nothing but V2, which is 9 volts. This is 9 volts, right? So we have extracted the data from the question. So we need to proceed with the procedure of the problem. Okay, so I'm deleting the question over here. V1 equal to 6 volts, right? So this is the data. So that is d theta equal to 5 degrees Celsius, T1 equal to 1800 seconds, V1 seconds, V1 equal to 6 volts, V2 equal to 9 volt, T2 T2 equal to 1200 seconds, and d theta dash is the quantity which we need to find. Okay, so I'm going to use the formula H equal to W into d theta. W into d theta. So what H is the heat developed, W is the heat capacity of the calorimeter, Joule calorimeter apparatus, and d theta is nothing but the difference in temperature, that is rise in the temperature of water. Okay, so what I'm going to do is H can be written as H equal to VIT, that is the product of voltage, current and time interval. By Ohm's law, I can split V as I into R because V equal to the product of current and resistance. So this will be IR into IT. So the value will be I squared into RT. I squared can be written as V by R by Ohm's law. I can be written as I V divided by R the whole squared into RT. So R gets cancelled. So I'll be left out with V squared divided by R into T. I'll be left out with V squared divided by R into T. This is the value of H. H is nothing but the heat produced. Okay. So I'm substituting here. So instead of H, I'm using this value as V squared by R, V squared divided by R into T, which is nothing but W into d theta. But in the first set of experiment, I have V1, I have T1, I have d theta. So I have V squared. Why come? So I'm going to substitute V1 instead of V and T1 instead of T. So if I do it, it will become V1 squared and T1. R will be same. Okay, resistance of the coil will not change. Okay, even if you take n number set of experimental value, if you take also, the value of resistance will not be changed and it remains constant. So R will be as it is. Only the value of voltage there is a change. For time interval there is a change, right? So now V1 squared is 6 squared. 6 6 are 36. 36 into temperature T1 is 1800 divided by R equal to what is W? We don't know. Just leave it as it is. Write it as it is. W into what is d theta? D theta is phi. Or I can write it as phi W. I can write it as phi W. W is nothing but the heat capacity, that heat capacity of the calorimeter apparatus. Okay, W is not watts. Okay, so is this is equal to 5W. So what is 36 into 1800? And the calculator is going. 36 into 1800. 36 into 1800 will be 64,800. It will be 64,800. 64,800 divided by R equal to 5W. This will be my equation number 1. Okay, I have formed equation 1 for the first set of values. Using the second set of values, I am going to frame equation number 2. Okay, so let it be this equation number 1. I am writing it over here. 64,800 divided by R equal to 5W. This is my equation 1. Now, I am going to find the values. I am going to find the equation for the second second set of values. I'm going to form the equation. So instead of V1, I'm going to substitute it with V2, and instead of T1, I'm going to substitute it with T2. So V2 squared, and this will become T2. So d theta, instead of d theta, it will be d theta dash. Okay. So what is B2 squared? B2 squared is 9 nines are 81. 81 into time interval is 1200 seconds divided by R equal to W into d theta dash. So 1200 into 81. 1200 into 81 equal to 97,200. So it will be 97,200 divided by R, which is equal to W into D theta dash. Okay, so this is going to be my second equation. So I am putting it here, 97,200 divided by R equal to W into D theta dash. This is my second equation number 2. So I got finally two equations from two set of values. So what I'm going to do is I'm going to divide equation 2 divided by equation 1. So equation 2 is 97,200 divided by R, which is equal to W into d theta dash. W d theta dash divided by 64,800 divided by R, which is equal to by 5W. So if I cross multiply, if I simplify this, it will become 97,200 divided by 64,800, which equal to W gets cancelled, so I'll be left out with d theta dash divided by 5. So now d into theta dash is nothing but 5 into 97,200 divided by 64,800. So the value is 97,200 into 5 equal to divided by 64,800 will be 7.5 degrees Celsius. Therefore, the answer is 7.5 degrees Celsius. Therefore, d theta dash is nothing but, what is a d theta dash? D theta dash is the rise in temperature of water. Rise in temperature of water, that is a d theta dash, is nothing but 7.5 degrees Celsius. 7.5 degrees Celsius. This is the answer, final answer. Okay. Thank you all for watching this video.